Hello. I'm making this video to show some troubleshooting and repair tips for the Dell OptiPlex 780 desktop PC. This is a very common model of desktop PC still used by many businesses. These instructions are also applicable to the 745, 755, and 760 models of Dell OptiPlex PC, also still in very common use in many businesses. For this demonstration, I have a OptiPlex 780 that has a failed power supply. To identify the failed power supply, I was able to plug it in and press the power button, and there's no activity on the chassis, no fan spin, and no activity lights illuminate other than a slight flicker. I can bypass some of the power supply functionality with a reset button on the back. Which indicates to me that a component inside the power supply has failed. To replace a power supply on one of these model systems, you open the chassis by pulling the tab on the side or top. Generally these are stood vertically on a desk, so this would be the top. And pull it backward, lift up on the side panel, and then put that somewhere safely out of the way. This is a pretty loaded system. You can see it has a video card, also 16 gigabytes of memory, and a media card reader in the front. These systems are very expandable, which is why they're so frequently used in business and home applications. It's completely capable of running the latest version of Windows 10, Microsoft Office. We use them here with triple and quad monitor setups for desktop office applications, routing software, database software. They're very versatile and easy to use, as well as easy to service. Any sort of servicing that you need to do to them can be accomplished with a basic Phillips head screwdriver. It's a mostly toolless chassis. There are a few Phillips screws in here. So I'm going to go through the complete teardown of this system, removing each component one by one, and I will pause to identify what each component is as I remove it. Since any of these components is prone to failure, hopefully this video will be helpful to other people who are working with similar model systems. So, to remove the optical drive and hard drive and media card reader, lift up on this tab, slide back. The optical drive is now free. I flip it over and disconnect the power and SATA cables. Actually, one of those was already unhooked because I was doing some testing before. We're actually going to disassemble this system down to the bare components, so we'll go ahead and remove everything. The SATA cable for the optical drive, the media card reader, which provides functionality for XD, micro SD, CF, memory stick. Additionally, it provides an extra USB port on the front of the system. Since there's only two built in, having another one here is helpful, since so many devices use USB. Unplug it from the motherboard. There's different types of media card readers you can install in this system. This particular one is an XM35U, which I believe is manufactured by AFT or AFI, AFT technology. Pull your power cables out of the way. Your hard drive is removed. Squeeze together the tabs on the side, push it back, and then lift up and out. This little carrier is just attached to the side with two retaining clips. The drives I use in our OptiPlexes are Seagate Fire CUDA hard drives. This is a 1 terabyte SSHD drive, which means a solid state hybrid drive. It has a combination of rotating, spinning platters as well as solid state memory like a SSD drive. We found these to be very effective in our operations from a cost-benefit standpoint. Turning the system to the side, we're going to go to the video card, which we don't have to remove to replace the power supply, but I'm going to remove it anyway just to demonstrate how it's done. To do that, flip that tab back, and there's a blue tab at the back of the card, which you release, and you can then lift the video card up and out. This particular card is an XFX Radeon 250 with HDMI and DVI outputs. So this card will support 2 monitors in this configuration. Of course, you don't need to use a video card with your Dell OptiPlex desktop PCs. We use them here for improved performance, especially on multi-monitor systems. We use a variety of cards ranging from 2 to 3 to as many as 4 monitors simultaneously. By using a graphics card, it helps improve the performance when using that many displays. So I'm going to set that over here on this anti-static sheet. So we're almost to the power supply now. I'll remove a few more components just to demonstrate how it's done. This sensor here is a chassis intrusion switch. This can alert you if anyone has tampered with the interior of the system or opened it for any reason. That's removed by sliding it towards me, down, up, and then it's just a small clip attaching it to the motherboard. This back panel lifts out. There's several different styles of panel. You can actually get them. It's pretty rare to see a model other than this, but there is another model that allows you to install full height expansion cards in a horizontal configuration as opposed to half height cards in a vertical configuration. Probably not something you'll see, but it is available from Dell. If we wanted to remove the processor, or if we were having any troubles with the front-facing fan, we would need to, for the fan, we would need to remove the motherboard. To remove the processor, it's 2 screws. And by taking this off, I'm now going to have to remove and install a new thermal compound. Anytime you remove and reinstall a CPU, you should always replace the thermal compound. So it's just 2 screws, one on either side. This also gives me a good opportunity to make sure the inside of the case is completely clean of any dust, pet hair, or anything. Once the screws are loose, the CPU heat sink snaps backwards and swings out. And you can see it does look like this thermal compound was due to be replaced anyway. It probably hasn't been changed in 6 or 7 years. The heatsink is very clean. I do frequently blow these out with compressed air just to keep them free of dust. Processor is located on the motherboard under this tab, or this socket. So to release it, you lift up on this spring-loaded arm, push that back, and I can now remove the processor. Again, this definitely looks like it needs to have its thermal compound replaced. This is an Intel Q9650 3.0 gigahertz microprocessor with 12 megabytes of cache. It is typically the most powerful processor that will work in a Dell OptiPlex 780 or 700 series desktop PC, including the 760, 755s, etc. You can also get a 3.33 gigahertz dual-core chip. However, for running Windows 10 and modern applications, having the quad-core at a slightly lower clock speed is going to be much more beneficial than having a dual-core at a higher clock speed. So again, the Intel Q9650 at 3 gigahertz quad-core is basically the best processor that one of these Dell OptiPlex 780s can accommodate. And it's very functional for database applications, mapping, business productivity, etc. Set that off here to the side. They typically go for around $40-50 on used marketplaces. So it's a very cheap, easy to install upgrade if you happen to be maintaining a large number of this type system. Just close that for now. The memory back here, as I mentioned, this system has 16 gigabytes of memory in 4 4-gigabyte sticks. The particular brand is G-Skill. Of course, there's a wide amount of memory available out there that will work in your Dell OptiPlex systems. This is PC3 10666 DDR3. You can see the numbers here. I've noticed that some of the newer G-Skill sticks don't work in these particular systems, but generally you can find memory on Amazon or eBay for $20 a stick or so that will work in these. And again, you know, maxing out the memory is obviously not something you need to do, but as we do use these in with a lot of applications open simultaneously, maxing out the memory to the full 16 gigabytes is very cost effective for us. So, to get to the power supply, which we're almost at, there's 2 connectors. The black one here, squeeze and pull, and near the front of the case is a small 4-pin connector that provides additional power to the processor. And again, that's also a squeeze and pull connector. Sometimes you have to wiggle it a little bit, it's kind of hard to reach over here at the front. Sometimes it helps to get the cords out of the way. There we go. And that is now free. One thing to be careful of with this type of system is there are some metal edges around the drive cage that can cut this cable. So I'm trying to carefully route it out in such a way that it doesn't get caught on any of those metal edges. So this long cable is now released. We're going to turn the system around. Where you can see a couple of the very few screws that are in this type of system. Those are released. Unscrew. Unscrew. There's a tab at the very top of the power supply, or the very front, depending on how you're holding it, right here. You just push that down, push the power supply towards the front, lift it out, and it has now been removed. I'm going to pause the video for a moment. Welcome to part 2 of my video. During the break, I cleaned off all of the old thermal compound from the CPU and heatsink, and also blew some compressed air into the inside of the case to remove as much dust as I could. If I were going to finish completely disassembling this PC, the final components to remove would be the motherboard, the RAM, the power button and front ports connector, the internal speaker, and the chassis fan. These would be removed. The motherboard is removed. It's held down by, I believe, a half dozen Phillips head screws. Turn this around. Should be able to see them here in the video. They're generally located at each corner, and one right there in the middle. You also need to remove this bracket that holds the heatsink down on top of the CPU, and that's also 2 Phillips head screws. So you'd remove all those components, pull this yellow cord here to release the connector for the front panel USB ports and diagnostic lights. The internal speaker can be removed by squeeze, lift it out, and then you would just disconnect its wiring harness. And the motherboard, you kind of have to slide it forward at a little bit of an angle, and then up, it'll slide out if you need to remove it completely. Best to just take your time, go slowly. You don't want to scrape any exposed elements on the motherboard along any of the metal edges inside the case. And then once all of that other stuff is out, then you can remove the fan. Fan is a pretty common thing to go bad, as is the fan on the power supply. Anything that interacts with or sucks in a lot of dust is going to wear out typically a little more faster than, you know, some of your more stable components of the computer, like for example the RAM or the motherboard. Fan replacement is a pretty standard thing on any desktop PC. Best to just keep it clean, and you can avoid a lot of that. So, to put the system back together now, let's go with our replacement power supply. Slide it in. Let's see. Kind of working around the camera here. That's now locked into place. Sometimes you have to wiggle it a little bit. I paused the camera for a moment there while I did that, and you'll hear it click once it's locked into place. This is a little tricky for me working with a camera right in front of the system. It's hard to get a good grip on things. So once the power supply is in, you take your screwdriver and reinstall the 2 screws on the back. Reconnect the motherboard power connector. Route the drive power connectors to where the drives are going to be once they're installed, and the 4-pin power connector up to the front of the system where it plugs in the 4-pin connector for extra power to the processor. Then we'll just go in the reverse of the reverse installation is reverse of the removal. So let's get our hard drive. Let's do our processor. This is keyed and it has an arrow on it so that it will only fit one way. Obviously, if it doesn't drop right into place, don't try to force it in the wrong direction. Pretty much you can just look for the little arrows or the little tab notches, and it should set right in there. Close the lid, lock it down. Get your thermal compound. This is not my preferred brand, but we ran out of the Arctic Silver. This is really not coming out very great, but once the heatsink is in place, it'll squish all that down. Heatsink just flips right down over top. Make sure your wires for your speaker and your internal fan are not being pinched. I tend to tighten it down a little bit on each side and go to the other side, tighten it down a little bit over there. If you're doing this a lot, this is much better thermal compound, Arctic Silver. It flows much more easily, spreads more easily, and has better cooling properties. So when tightening these screws down, you do want to get them tight, but you don't really want to over tighten them and strip out the threads. Let's get our back plate, and that just drops in here. Our graphics card. Flip that to lock it into place. Let's get our hard drive power connector. Sorry if I keep moving around a lot. It's a little more challenging doing this with a camera right in the way of where I'm working. Our SATA cable for hard drive data to the motherboard. Media card reader. Most of these connectors, you might notice, are keyed so that it's impossible to install them backwards. our optical drive, which can be a CD-ROM, DVD, Blu-ray, etc. These out of the way a little bit. Just snap right into place like it did. Those in. Get our chassis intrusion switch. Just go through and make sure I've got everything. Looks like it's nice and tight. We'll check the RAM, make sure everything is tight. You could also give it another little blast of compressed air. Alright. So we're going to close it up. Around. Let's plug in video. Grab a mouse and keyboard. Power connector. I don't know if you were able to hear it just now, but the system did just do its brief power test where it spun up the fans to verify that everything has power. So, let me raise my camera up a little bit. We're going to power the system on. We can press F2 to enter the system BIOS. There's also diagnostic lights here across the front where it has a 1, 2, 3, and 4 where you can see it running some self-tests. So the system is now powered up. Now that we have the system put back together, I just wanted to show a quick clip on accessing the system diagnostics. Press F12 at the Dell logo screen. It's F2 to enter the BIOS, F12 to enter the diagnostics. You can scroll down to the diagnostics option, click on that. It's going to run the system through a variety of diagnostic tests to verify that all of the installed components are operating correctly. It'll test the RAM, the processor, hard drive, optical drive, different tests depending on the version of the BIOS and the model of the system. But anytime you're repairing or working on any sort of Dell OptiPlex PC, once you're done and before you issue that machine and put it out in the hands of a user, you should always just make sure it passes all of the BIOS tests. It can help avoid issues like, for example, bad stick of memory is easily detected by running through these BIOS tests. For the third part of my video, we're just going to look briefly at some of the BIOS settings within the Dell OptiPlex 780 desktop PC. You can see on the main screen some general information about the system. You can see that it has 16 gigabytes of RAM. It's 1033 megahertz, but the 780's clocked that at 1066. It has 4 gigabytes of RAM. There's the Q9650 processor that we talked about with 12 megabytes of cache. The PCI slot 1, the video graphics card. the date, the time, the boot sequence. I typically optimize these settings as best as possible. You know, with the latest A15 BIOS or whatever the latest BIOS is, should you be watching this for a different type of system. Always try to make sure that you are on the latest BIOS available from your manufacturer. That frequently contains performance improvements and bug fixes. In particular on newer systems with the newer generation Intel processors, it contains fixes for various vulnerabilities that have been identified in the processors. So always try to update to the latest. You can see that I have this configured as a boot device, that 1 terabyte SSHD hard drive. Drive, just get drive, disable it. You don't have one, I don't have one, nobody has them anymore. Sata Operation, RAID, AHCI, or RAID on. I think AHCI enables some additional features. Smart reporting on drives, disable anything you don't use. System configuration, integrated NIC, enable, USB for Flex Bay. These are things that are specific to the media card reader. USB controller, you can enable it, you can set it to not boot if you don't want to allow booting from the USB devices. Parallel port, this is something that I would typically disable unless you have a specific need for a parallel port. Same thing with the serial port, just save system resources, disable it if you're not using it. Miscellaneous devices, I usually leave these all turned on. This is your PCI slots, front, rear, USB, audio. You may want to disable those in some instances where if you don't want somebody accessing the front USB ports on a system, for example, if you're worried about, you know, somebody plugging in a flash drive, you know, stealing company data, stuff like that. There are business reasons why you might want to leave those disabled. Video, primary video, auto, performance, multiple core support, turn that on. Speed step, turn that on. C-states control, turn that on. Limit CPU ID value, turn that off. Basically just optimizing for performance. Virtualization, I usually leave the first two on and turn the third one off. Security, the only thing on here I might set is the TPM security. I'll activate that. CPU XD support, I'll activate that. OROM, activate. CompuTrace, deactivate unless you're paying for the service. Signed firmware update. This is a good security feature, but generally if you're administering the firmware yourself, it's not something that you're going to need to worry about. Chassis intrusion, we're going to clear the intrusion warning since the system did have the intrusion switch. SATA password, this is some more security options you can set if you choose to. Power management, AC recovery, power off or on, it's your choice. If you want the system to automatically turn back on in the event of a power failure, power is restored, you can have it turn right back on. Auto on time, have the system turn on every day at a certain time. Like I'll set mine to turn on every day at 6 a.m. just to make sure if somebody does accidentally turn one off that they're on in time to, you know, for when the person starts work the next day. Low power mode, turn that off. Remote wake up, you can turn that on or off. I leave it on so I can remotely wake up the PCs. Suspend mode S3, fan control override, don't turn that on or the system is going to be really, really loud. Maintenance, service tag, asset tag, serial message, this is all just things you can set. Image server, I don't think anybody uses a Dell image server. If you do, you would set that in here. Post behavior fast boot, turn that on. Enable numlock, turn that on. Enable F12 boot menu on. Keyboard error detection, why would you want to turn that off? MEBX hotkey, OS install, turn that off. System logs, you can see here there's some chassis intrusion alerts from when I had the system open. I'm going to clear those out. And that's pretty much it. Basically it's just a process of optimizing a little bit, you know, making sure that the best settings are turned on, and other ones, things you don't need like serial parallel port, are turned off. Obviously if you do use those, you would want to turn those on. Hope this has been a helpful video to you. If you like it, please thumbs up and subscribe to my channel. I do various computer repair videos as well as you know, automotive repair, basically anything I'm working on, which is a wide range of stuff. I'll try to videotape it and put a video on here, and hopefully it will be helpful to you. Thank you.